Okay, so we're going to look at the change of base rule for logs. Okay, so this will appear in your book as something that looks like this. Log to the base of a of x is equal to log to a different base of x and log to a different base of a. Now you can have whatever you like as your base, as long as it fits the base rule. So whole numbers and positive, you can have anything you like in there. Not whole numbers, you can have any base that you like in there. You can have e, you can have log to the base 10, you can have log to the base 5, and it doesn't matter which base you choose unless it helps you to solve the problem, right? So this idea used to be really big in maths because we didn't have a CAS calculator that could do log to the base 2. All we had was a table of values for log to the base 10 of x and log to the base e of x. And so if we were trying to solve something that was an exponential function, so 2 to the x is equal to 0.5, say for example, which is not a good example. But if we wanted to write this as a log equation, it would become log to the base 2 of 0.5 is equal to x, and then we couldn't look up this value. There was no way to do it. And so what we would have to do is rewrite this thing here in either log to the base 10 or log to the base e, either one of those, so that we could use our table of values. That's what it's for. And so you're probably wondering, well, why the hell would you need to be able to use it anyway? And I'll show you in a minute how log to different bases can be used to do transformations from one log graph to another log graph with a different base. Okay, so change of base rule is that rule there. There's a derivation of it in the book, in the Essentials textbook. You don't ever have to derive it. Okay, it's just a proof. It's not even a proof. It's just a little bit to show you how it works. But you can use change of base to simplify things like, for example, something like log to the base e of 27 divided by log to the base e of 3. So you can see that both of these have the same base, both log to the base e. So it looks like this side of the equation here, doesn't it? So we can use this in reverse to write it as just a single log. And if we do that, try using a pen. If we do that, we get that is equal to log to the base of 3 of 27. Yeah? Which is log to the base 3 of 3 cubed. Bring the 3 out the front. Log to the base 3 of 3 is 1. So it simplifies to 3. Okay, so you need to be able to remember how this whole thing works. And so you saw that I pulled this one apart here. I pulled this one apart and immediately put the 3 at the bottom and the 27 as what it is you're finding the log of. And there is a definite pattern here, and this is how I remember which way to do it. Okay, so let me just get a highlighter here. So your a, log to the base a, see that's a little bit lower than everything else. It ends up on the low side of that equation. And see the x is kind of on the top. The x kind of ends up on the top. So if I had them as different colours, I'm just going to write over. That didn't work very well. Log to the base a, the a is on the bottom. And log to the base x, log of x is what you're finding. The x ends up on the top. Okay, so I'm going to get you to have a crack at another couple. I'm going to write them on here. I want you to pause it, do it, and then see what you get. Okay, there are the questions. Away you go, press pause, and when you're done, unpause and check your answers. Okay, how did you go? If you need to, press pause and check you're working all the way through. There's the answer to the last one. So we're going to have a look at a VCAA question. You can see it's from 2011 Exam 2, and it's question 22. So the question asks us to go from a log plus a log plus a log to a fraction with a log on the bottom, a fraction with a log on the bottom, plus a fraction with a log on the bottom. And on the top of each of the fractions is a 1. And this is a common pattern that you'll see in VCAA questions. So what we need to do is to turn 3 logs into 3 fractions involving logs. And to do that, we're going to use change of base. So I'm going to colour up each of the logs and then write each one as a change of base form. So here they are. So the red one becomes this, the blue one becomes this, and the green one becomes this. So now I need to turn these top numbers in the fractions, the numerator in the fraction, into a 1. So for the red here, to turn this into a 1, I need an A here and here. So this becomes 1 over log to the base A of C. Now this might be enough to identify an answer. Let's have a look and see if we can find some. There's one there. That might be enough to get us an answer. Let's do the blue log and see what we get. So to get a 1 on the top here, we need a B here and a B here. So that's going to give us 1 over log to the B of A, which is what we've got in this next little section here. So it looks like we've got the right one. Let's just check that this is what we need for the last one. So to make a 1 on the top of the green one, we need a C and a C. So that will make it 1 over log to the base C of B, which is what we've got here. So our answer is B. There was a similar multiple choice question to this in the 2019 paper, and here it is here. Again, it's the last question in the multiple choice section. So pause the video, have a go, and see how you go with this one. So press pause and have a go first. Now, if you wanted to check your answer using your calculator, all you need to do is to put in the initial equation equal to, and then options A, B, and C, and what you're looking for is the answer to tell you that it is in fact true. If it's true, then it's correct. If it just spits you back something ridiculous, that means that it's false and it's not the correct answer.